Here's question number 1 from page 621. Nissan or Toyota? So they want to find out the satisfaction rating on these vehicles. And they're just going to ask them if they're satisfied, and it's really just a yes or no question. So they select a random sample of 400 Toyota owners and 400 Nissan owners, and they just ask this question. Would you say that you are generally satisfied with your Toyota or Nissan vehicle? That's just a yes or no answer. So out of this 400 people, we're just going to get a number, like 120 out of 400. So that's going to be a proportion. Now, that is the answer to letter A. Is this problem about comparing means or proportions? Because it's a yes or no question, it's got to be a proportion. We're just going to see how many out of the 400 like their car. Letter B. What type of study design is being used to produce the data? Well, we're not doing anything. We're just asking them a question. It's just kind of a survey sort of thing. We're not performing any kind of experiment. We're not asking them to do anything or try anything. So this is an observation. Letter B. It's an observational design. So there we go, observational study. Let's look at question number 3. Number 3, do people that play computer games do better when they are cheered on? Someone is there watching them play and cheering them on, or does it not matter? Now, let's see, 50 teenagers are experienced playing a particular computer game, volunteer for the study. We randomly assign them to either play with someone cheering them on or playing by themselves. Okay, each player's score is recorded. That's important. Is this problem about comparing means or comparing proportions? Explain. Well, it's comparing means because we're going to have a score for their game. So that's not just a yes or no. We're going to take the score for the game and we're probably going to average it. The average score when they had a cheering person and an average score when they did not. So, letter B, what type of study? It is a randomized experiment. It's an experiment because we're doing something. These people are participating in a thing. For instance, they have someone in the room cheering them on. That's part of the experiment. Okay. And if you remember, that would be called the treatment. The treatment that they get is that they get someone in the room cheering them on. Next. Okay, number 5. This company makes 2 different bags of jelly beans, one for kids and one for adults. Now they say that the child mix has 30% red jelly beans. So let's just put that as this. Maybe we'll just put for child, right, is equal to 30%. And then the proportion of red jelly beans for the adult is 15. So, like that. One for child and one for adult. So they take 2 samples. One is from the child's mix. So, I suppose I should do this in C, I guess, right? There were 50 for that one. And then and for the adult, the amount in the adult sample was 100. Now I'm going to do 0.3 times 50, and then 0.7 times 50. Can you guess what I'm doing here? And then 0.15 times 100, and 0.85 times 100. Those are all bigger than 10, okay? Bigger than 10. So we have to do all that stuff, the random, normal, independent. So this is the normal, and we're going to assume that there are over 500 in the complete bag of jelly beans and over 1,000, right? In the big jar of mixed for adults. Anyway, so now let's take a look at the standard deviation is a little bit different on this. But it's really not so bad. It looks pretty gnarly, but all we're doing is we're just combining. Look at that big square root. So what we're going to do is, you might even be able to guess, 0.3 times 0.7, and we're going to divide that by 50. Then we're going to add that to 0.15 times 0.85 and divide that by 100. So that's the new way that we get the standard deviation in this situation. And that standard deviation turns out to be 0.074. So that's what we're going to work with. So this is our standard deviation. So here we go. Find the probability that the proportion of red jelly beans in the child sample is less than or equal to the proportion of red jelly beans in the adult sample. So check this out. If we subtracted those two, if we subtracted the child proportion from the adult proportion, we would kind of expect it to be this. It would be 0.3 minus 0.15. So we should expect, if things were true, to get a value of about 15. That's what we expect. But we want to see if it's the same and we subtract them, we're going to get a 0. So we want to see what's the probability that it's 0 or less, right? So that's our z-score. So what we're going to do is, here's our z-score, and this is what we're interested in, 0 or less, and minus what we expect, which is 0.15, divided by our standard deviation. Okay, let me do that. And the answer to this is negative 2.03. What do we do with that? Normal CDF. Okay, we are saying that we're way down here, here's 0, way down here, 2 over 2 standard deviations away from the middle. And we say, what is the probability that it's less than that? So it's underneath the graph here. So it's normal CDF. And we do not subtract from 1 in this case. So that's the area of the graph that we're looking for. And it works out to be 0.0212. 0.0212. That's the area of the graph down there. So what does that say? There's only a 2% chance that if we take 2 random samples and subtract them, that the adult sample would have more red jelly beans than the child sample. There you go. Now letter B says, suppose that the child and adult samples contain equal proportions of jelly beans. Well, based on part A, there's only a 2% chance that that would actually happen. So if we just take one sample and we happen to get equal proportions, we would say that doesn't seem very likely. So you might think the company is not being very truthful about the proportion of red jelly beans. Okay, there you go.